In today's lesson, we're going to learn about exponents. Pause this video and grab your workbook and open to page 203. On page 203, we're going to see how we can use exponents to write numbers. In the example, the expression 3 to the 5th is called a power. The base is 3 and the exponent is 5. We're going to use exponent notation to complete the table. Now, numbers can be written two ways. We can write them as a power, or we can write them in repeated multiplication form. Repeated multiplication is taking that base number and expanding it the number of times represented by the exponent. So in example 1 of this table, we can see that the base is -3. So -3 is being multiplied by itself one time. And the value of -3 is -3. -3 to the second power is taking that base of -3 and multiplying it by itself 2 times. The base is expanded times itself 2 times. -3 times -3. The value of -3 times -3 is +9. -3 to the third power is -3 multiplied by itself 3 times. -3 times -3 times -3. -3 times -3 is 9. Times -3 is -27. Go ahead and finish the table on your own. Pause the video while you do that. In our interactive notebooks, we're going to take notes on exponents. As you saw in the previous example, a number can be written as 3 to the 5th power, 3 being the base and 5 is the exponent. That means we're taking 3 and we're multiplying it by itself 5 times. 3 is used as a factor 1, 2, 3, 4, 5 times. Be careful, it is not 3 times 5. 3 times 3, that product times 3, that product times 3, that product times 3. And that's how we get 243. There are some rules that you have to keep in mind when you're working with exponents, and we'll get to those starting in 10.2. But first, let's take a look at writing expressions with exponents. It's basically the reverse of what we were doing earlier. So if I see that I have -7 multiplied by itself 1, 2, 3 times, -7 is my base, 3 is my exponent. -7 to the third. -7 is the factor 3 times, so the exponent is 3. If at any point you're writing these notes, clearly I'm not writing them, I'm just presenting them to you. They're already written. Pause the video, write the notes in completion. I will be looking for these notes tomorrow. Pi times pi times r times r times r. That is the same as pi to the second power times r to the third power. If you notice, pi is a factor twice. Pi times pi, there's 2 of them being multiplied twice. So that's how I get pi to the second power. R times r times r is being used as a factor 3 times. so the exponent is 3. They are combined, still with a multiplication symbol, because this is all multiplication. Negative 2 to the 4th power. Negative 2 to the 4th is the same as negative 2 times negative 2 times negative 2 times negative 2. Our base is negative 2, and that is a factor 4 times. So I expand that to negative 2 times negative 2 times negative 2 times negative 2, which is positive 16. Remember your rules. Negative times a negative is a positive. Positive times a negative is a negative. Negative times a negative results in a positive. And that's how we get 16. Now you can see that these look very similar. The difference is that in the first example, negative 2 is the base. In the second example, 2 is the base. That means that the negative is only here once, but the 4 is the product 4 times. 2 times 2 times 2 times 2. You can see the result is different because in this first example, when we did negative 4 times, we got 16 as a positive. And in the second example, 2 times 2 times 2 times 2 is 16. But we have this negative sign, which gets carried over into our answer. It's important when you're evaluating expressions that you're very cautious about your order of operations. Let's take a look at this next example. 3 plus 2 times 3 to the 4th. Now, I've already expanded into the next part of this example. 3 plus 2 times 3 to the 4th. Order of operations tells me that I need to do this exponent before I do addition or multiplication. So I've simplified this to 3 plus 2 times 81, because 3 to the 4th is 81. I've taken this further. 3 plus 2 times 81. Order of operations tells me that I do multiplication before addition. 2 times 81 is 162. So I'm left with 3 plus 162, and that gives me 165. I'll just highlight the steps to know that this is what I did first. 3 to the 4th. That's how I got 81. Why don't you go ahead and try this one on your own? 3 to the 3rd power minus 8 squared divided by 2. Go ahead and pause the video while you work out that problem. Remember your order of operations. Okay, so you should have done your exponents first according to order of operations. 3 to the 3rd power is 27. 8 to the 2nd power is 64. 27 minus 64 divided by 2. Next, we have subtraction and division. Order of operations says division comes first. 64 divided by 2 is 32. 27 minus 32 is negative 5. Did you get negative 5? On the left-hand side of your notebook, go ahead and try these practice examples. Now that you've had a chance to try these, I'll go through the answers. -5 to the 4th power. That's telling me that -5 is being expanded 4 times. -5 times 5 times 5 times 5. Be very careful that that negative sign is not in parentheses with the base. So I only have that negative out there once. I don't have it with each product. -5 times 5 is -25 times 5 is -125 times 5 is -625. Now I should not see you using the exponent button on your calculator. What I need to see is that you're expanding this base to the number of times that you see in the exponent, and then you should be doing this multiplication. I'm okay with you doing this multiplication in your calculator. You don't need to be able to do this in your head, but you should not be using -5 to the 4th power in your calculator. You should be writing it out this way. -1/6 in parentheses to the 3rd power. That means I have -1/6 3 times. Now, if you remember your rule for multiplying fractions, when you multiply fractions, you multiply straight across. -1 times -1 is +1 times -1 is -1. 6 times 6 times 6. Well, 6 times 6 is 36. Times 6 again is 216. If you forgot what these mean, I hope you asked the buddy. These lines mean absolute value. Absolute value talks about your distance from 0. For example, if I consider a number line, and I have 0, 3 is 3 units away from 0. -3 is also 3 units away from 0. We don't say that it's -3 units away. It is 1, 2, 3 units away from 0. The same as +3. If I had 2 and -4, and I said, which is greater, the absolute value of -4 or 2, I would say, well, 2 is 2 units away from 0, and -4 is 1, 2, 3, 4 units away from 0. So actually, the absolute value of -4 is greater than 2. Absolute value is always going to be a positive number. So if I look at what's inside these absolute value signs, I see -3rd to the 3rd power. Remember, the negative is not in the parentheses, so it's -3 times 3 times 3 divided by 27. And the absolute value symbol comes back. -3 times 3 is -9. -9 times 3 is -27. divided by 27. Negative 27 divided by 27 is negative 1. But remember, that's in absolute value sign. The absolute value of negative 1 is asking you how far away from 0 is negative 1. And that is 1 unit away. 9 minus 2 to the 5th times 0.05. According to order of operations, PEMDAS, I need to do exponents first. 2 to the 5th power is 2 times 2 times 2 times 2 times 2, 5 times. 2 to the 5th is 32. I bring down the rest of the expression. 9 minus 32 times 0.5. According to PEMDAS, multiplication comes next. 32 times 0.05 is 16. 9 minus 16 is negative 7. At this point, I would like you to open your workbook to page 206. On page 206, you're going to practice writing a product using exponents, evaluating an expression, just like the examples we just did. So open your workbook to page 206 and do numbers 1 through 10.